In this episode, we will be talking about our changing view of the universe, how the human conception of the universe has changed fundamentally over the past 2,500 years. Let's begin with a simple observation. If you were to go outside tonight and look at the night sky, you would observe stars and planets and the moon, and during the day the sun as well, moving together across the sky. This motion is known as apparent daily motion. Apparent daily motion is simply when celestial objects, including stars, planets, the moon, and the sun, appear to move across the sky each day. This is nothing new. People have been observing this for thousands of years. It wasn't until about 2,500 years ago when astronomers, philosophers, and mathematicians began to formulate a model for the universe based on this observation of apparent daily motion. Let's go back to one of our first astronomers, Plato. Plato was a Greek philosopher and mathematician who lived between 423 and 347 BC. He was shortly followed by another Greek philosopher, Aristotle, and then a couple hundred years later by Greek astronomer Claudius Ptolemy. Now together, these three astronomers were able to formulate a fairly good functioning model of the universe, seen here. Now note one interesting thing about this model. In the center of everything is the Earth. As a result, this became known as a geocentric or Earth-centered model. Let's define this term. A geocentric model is a model of the universe in which there is a stationary Earth. The Earth is sitting still in the center with other celestial objects orbiting it. It is an Earth-centered model. This makes sense if you think of the observation of apparent daily motion. It certainly looks as if the Earth is sitting still and everything else is moving around us, and this was the basis for this model. Let's take a look at Claudius Ptolemy's geocentric model, which was proposed around 100 AD. In the center, we see Terra, which is the Earth, sitting still, not spinning, not moving at all. Around us orbits the moon, labeled here Luna, and then you see some of the inner planets, Mercury and Venus, and then there's the sun. Now notice how Mercury and Venus have these odd orbits on which they're kind of traveling on a smaller orbit around a bigger orbit. This was known as an epicycle, and this was a necessary addition to the model in order to explain what we were observing. Zooming out further reveals additional planets including Mars, Jupiter, and Saturn. At this point, Uranus and Neptune had not yet been discovered. This model was largely accepted for more than 1,000 years after it was formulated by Claudius Ptolemy. Everyone took for granted that the Earth was sitting still in the center. Additionally, they felt that the Earth was a perfect sphere, created by God and with no imperfections whatsoever. As time went on, however, issues arose, and approximately 1,000 to 1,200 years later came astronomer Nicholas Copernicus, seen here. Copernicus was a Polish astronomer born in 1473 and who died in 1543. Ironically, Copernicus worked for the Church. In his spare time, he made observations of the night sky and formulated a radical new view of the universe. Working in a similar time period was Galileo Galilei, famous for his work with the telescope. Together, Galileo and Copernicus formulated a brand new radical model of the universe that went directly against the accepted geocentric model. Their model was a heliocentric model. In a heliocentric model, the sun, not the Earth, is in the center, and all other objects, including the Earth, orbit the sun. In this model, the Earth is moving in two ways. It revolves around the sun, and it also rotates on an axis. As you can imagine, the heliocentric model proposal was quite controversial at the time, because it suggested that the Earth was not perfect at all, and in fact the Earth was not special, as it was orbiting another object just like the other planets did. This sun-centered model, though, could not be ignored, as it perfectly explained the observations we were seeing. Let's take a look at a geocentric model and heliocentric model next to each other, just for comparison. The geocentric model on the left has the Earth sitting still in the center, with the planets making these complex movements around it. The heliocentric model is much neater, with the Sun in the center and the planets orbiting simply around it. The heliocentric model was eventually accepted because it better predicted our observations. We could finally, for the first time, predict exactly where a planet would be on a given date at a given time, and according to this new model, it would work. But there was more work to do. Along comes Johannes Kepler, a German mathematician who lived from 1571 to 1630. Soon after Kepler did his work, Sir Isaac Newton came along, an English physicist who lived in the late 1600s. Kepler and Newton both tried to solve the problems that remained with the heliocentric model. Kepler's observations were very important. He was the first astronomer to look at the shape of planets' orbits as they were going around the Sun. To this day, astronomers and the public felt that planets moved in these circular paths. But Kepler made a rash prediction, which was that planets didn't move along perfectly circular paths, but rather along oval paths, as seen here. These oval paths are known as ellipses. In addition, Kepler noted that when an object orbits a star, its speed changes, as seen here. Far away, it slows down; closer, it speeds up. These observations would further be explained by Isaac's observations of universal gravitation. Ultimately, the conclusion was made that all orbiting objects travel along elliptical, oval-shaped paths. Yet another argument against the idea of perfection in space. In fact, nothing is perfectly circular. Additionally, it was noted that objects would speed up when closer to what they are orbiting due to the pull of gravity. And so speeds change, orbits are different shapes. Essentially, everyone's conception of the universe was changing with each observation. Which leads us to what we have today, a heliocentric model of the solar system, in which the Sun is in the center and the planets all orbit along elliptical paths, speeding up and slowing down as they orbit the Sun. One more thing to note. Early astronomers had no clue how vast the universe truly was, and so when they formulated a model of the universe, what they were really talking about was simply a model of our solar system. Of course, today we know that this is just a tiny, tiny, tiny piece of the entire universe. Regardless, this heliocentric model has been proven true by modern technology, and we owe this to all the hard work of the early astronomers.